Hello everyone, welcome to SSJB's Mentora. We have already started our discussion of signals and system. So let's continue that further discussion of signals in this video. Today we will study some more types of signals which comes under the various category. Like the first is the deterministic versus non-deterministic. If I am having any signal, if I am able to formulate it with some specific kind of formula or logic, then it's a deterministic signal. Like the example, we can take the sinusoidal x of t is equals to sine t. The x of t is equals to sine t. Like the sinusoidal curve, if I am able to formulate it with some kind of formula, then it's a deterministic signal. But if I am having any raw sequence, discrete sequence like 1, then 10, then 20, or then let's say point 0.2, point 1, point 0.5, some kind of random sequences there, then it's difficult to formulate it. So it's a non-determinate. It's a kind of signal. It will give some kind of information, but we cannot formulate it with specific kind of formula. So this is the deterministic versus non-deterministic. Now next comes the causal versus non-causal signal. Causal simply tells us that if the signal is present for the positive time interval, the signal which only present only in the positive time interval of the timeline, then it's a causal signal. And that property, the signal which don't follow that property is the non-causal. Like it simply says that if this is the timeline and this is the positive time interval from 0 onwards, so signal which presents only here, then this is the causal signal. The very good example of the causal signal is the unit step function. We have already studied in previous lecture that how unit step signal looks like. It start with 0 and having the constant value. Okay, so this signal is present for positive time interval only. Okay, this is the unit step function u of t. This is present for positive time interval only. So this is the causal signal. And the signal which is having some kind of values in negative time interval are the non-causal signal. There is also one property, the anti-causal. We will see once we start to discussing various examples related to causality and non-causality. Then third comes the periodic and non-periodic. If any signal repeats itself, if any signal repeats itself after some kind time interval, after some kind of time or time interval, then it's a causal signal. Sorry, it's a periodic signal. If I have started, okay, sine, cosine are the periodic signal because they follow some kind of this notation. Like if sine 0 at this position, sine 0 is 0. Okay, but once I will complete this periphery, once I complete this circle, then after 360, then sine 2 pi, I can say, or sine 360 is also 0. Okay, means after some specific time interval, that value is remained same. So it's a means it's repeating its value like 0, 1 as for the sine 0, 0, sine 91, and further some values. And again for 2 pi, sine 2 pi is 0. Again after 2 pi, like sine 4 pi, it will remain 0. So this is the periodic signal which repeats itself after some kind of time interval. We can also formulate it with some kind of if x of t is equals to x of t plus capital T. T is the fundamental time period. We can also calculate its frequency by f is equals to 1 by t. Okay, so this is the periodic versus non-periodic, and signal which don't follow these kind of properties, which don't follow this kind of notation, it's the non-periodic. Now next we will start with the signal operations. There are various signal operations performed on the signals. First is the amplitude scaling. If I am having any sequence, let's discuss only sine signal because it's easy to understand. If I am having x of t, the sine signal, sinusoidal curve is there, and it's, let's say its amplitude it's 5 volt. Okay, amplitude scaling they are saying. And For the x1 of t, its amplitude is increased. Okay, so I will draw like this. Its amplitude is increased. Just ignore my drawing. Just the important concept is the 15 volts, let's say. The amplitude volt or whatever the unit you can say. The 15 volt and 5 volt. So x of t, we can denote it as x of t is equals to a sine of 2 pi ft. This is the notation where a is the scaling factor. Here scaling factor might be 3, that 5 volt is increased to 15 volt. So scaling factor is 3, a is 3. So this is the amplitude scaling. Then next comes the time folding operations on any signal. So I will draw one curve so that we can understand it easily. If I am having this kind of curve or the signal, let's say it's a signal, it's x1 of t. Okay, so time folding is just the folding of the signal. The name itself suggests the folding, also called as the time reversal. Its another name is time reversal. Time reversal. Okay, so we need to reverse it or fold it. But how will fold? Just we want to place some kind of object or mirror at the origin. Then we need to just flip it. Okay, so it will look like this. It is just flipped at this origin. Mhm. Don't see my drawing, but the concept is that it's folded across this origin or the across this axis. So this is the time folding. And its equation is changes as, so this, let's say it's x2 of t. I'll write here that x2 of t is equals to x1 of minus t. Folding is this. T is the original signal, minus T represents the folded signal or the folded sequence. So this is the time folding, and this is this we have seen the amplitude scaling. Now let's move to the next. Next is the time shifting. There are multiple time shifting properties, multiple formulas are there, which are very simple. First, we need to understand how the original signal looks like. If I am having x of t, this is the original signal, like we have discussed previous, that this is the original signal and time folding is like this. Okay, so if I am having x of t, the original signal, I can perform the various shifting properties, shifting operations on that. So if I write x of t plus 2, or let's say n, not 2, it will be very specific. We'll take n, x of t plus n. Then this is the shifting of that signal by n units, but in which direction? In the left direction. This is the left shift. This is the left left shift by n units. Okay. Now next comes the x of t minus n. T minus n denotes what? The right shift. Right, right shift by n units. Okay, so this is the first, the x of t plus n, which is the left shift by n units, and x of t minus n, this is the right shift by n units. Now the third comes is the time reversal. Okay, third comes the time reversal, the x of minus n. As earlier we have seen, it's a time reversal or time shifting. Time reversal. Then fourth comes, if I am having, now the change happened is the original signal was x of n. If I add n units to it, x of t plus n, then it's a left shift. And if it's a x of t minus n, then it's a right shift. But exactly opposite things happen with the shifted signal. Now we have reversed the signal x of minus n. Now we will perform same operations on that x of minus n only. Now x of minus n plus x of let's say minus t, sorry, not n, x of minus t will be here, x of minus t, and here also x of minus t, x of minus t plus n. N are the units with which want to shift. Okay, if it's x of minus t plus n, then this is the right shift, right shift by n units. And if similarly, we can guess that if it's x of minus t minus n, then this is the left shift. So this is the left shift by 10 units. This is the left shift by 10 units. So summarizing this, we can conclude that whenever I am having the original signal x of t, and if I perform the x of t plus n, let's say for example x of t plus 2, then that signal will be shifted to left. It will be shifted to left by that units. If it's 2, then it will be shifted by 2. And similarly, if it's x of t minus n, then it will be right shifted by n units. But once I reverse that signal, then x of minus t plus n will be right shift only by that specific n units, and x of minus t minus n is the left shift by n units of what? The folded sequence. We will see with example once we start the discussion of the examples related to the operations on the time. Then last is the time scaling property. Now I'm having, let's say again take the sinusoidal curve. This is the sinusoidal curve. I am having x of t. Time scaling means what? The compression or the decompression, or what we can say expansion and the compression. So if I do the compression graph will look like this. The sinusoidal curves are the compressed. Now its equation will change as x1 of t, and as this is the compression, x1 of t will be x of 2t. This is the important equation. And 2t or nt, we can just for the simplicity, we have x of t is equals to x of 2t. Means once we multiply the time variable by 2, multiplication is there is the compression. This is the compression graph. And if I draw the expansion, if this is the expansion of this, I will draw it more clearly. If this is the expansion of this original signal, then its equation will look like, as this is the expansion, its equation x2 of t, that x2 of t will be the x of original t by 2. It's see, dividing the time variable of the original signal by any unit will do the expansion of the original signal. We'll highlight that this is the expansion formula or the expansion term. Okay, so summarizing this video, we have started with the various different types of signals. What are the deterministic, non-deterministic, causal, non-causal, and the another types of signal like the periodic and non-periodic. When we started with the operations on signals, various operations we have seen. The first two operations were the amplitude scaling, then the time folding we have seen. And on this slide, we have seen the time shifting, various time shifting properties. And the last is the time scaling properties, how the expansion and the compression looks like. In the next video, we will directly start the system. We have already seen the definition of system, how it looks like and what it does. We will directly start with the types of systems. Thank you.